Hi, today we are going to look at writing polynomial equations with given roots and finding the roots of polynomial equations. So our first example is asking us to write the polynomial equation with the roots 2, negative 3i, and positive 3i. We are going to use the corollary to the fundamental theorem of algebra to set up our equation. I know that every single root can be written in a quantity x minus the root. And what we're going to do is multiply all those factors together to get our polynomial equation. It's asking for a polynomial equation and not a function, so I'm going to set this equal to 0. So 0 equals the quantity of x minus my first root, which is 0, or 2, times the quantity of x minus my second root, negative 3i, times the quantity of x minus my third root, 3i. In Algebra 2, when you looked at these complex binomials, you multiplied any binomial with a complex number in it together first, and that's what we're going to still do today. So 0 equals the quantity of x minus 2. Since I have a binomial times a binomial, I'm going to FOIL. First times the first is x squared. My outsides, x and negative 3i, become negative 3i. My insides, we're going to simplify a little bit first. A negative minus a negative, or negative times a negative, in our case, is a positive number. So insides are 3i times x, so I need plus 3ix. And my lasts are 3i and negative 3i. So negative 3 times positive 3 is negative I times I is I squared. In Algebra 2, we learned that I, the imaginary number, is equal to the square root of negative 1. Therefore, if we have I squared, if I square both sides, the square root disappears, so I squared is equal to negative 1. And that's going to help us do a little simplification here. So I'm going to cross off I squared, and I'm going to multiply negative 9 by negative 1. I'm going to reduce these terms because negative 3ix and positive 3ix go to 0. So I'm left with the quantity of x minus 2 times the quantity of x squared plus 9. I, again, have a binomial times a binomial, so I'm going to FOIL. X times x squared is x cubed. Negative 2 times x squared is negative 2x squared. 9 times x is positive 9x. And negative 2 times 9 is negative 18. So my polynomial equation is x cubed minus 2x squared plus 9x minus 18. Graphically, if we were to graph this, I would have a degree 3, so I should have 3 roots, which I do. They were 2, 3i, and negative 3i. And looking at our roots, we can tell that we are going to have one x-intercept, 2. 3i and negative 3i, those complex imaginary numbers, do not cross x-intercepts, or cross the x-axis. So we know, in some direction, our graph is going to look something similar to that, with one x-intercept at positive 2, with our end behaviors going in opposite directions because this is an odd degree. Our second example today asks us to find the roots of the following polynomial equations. So the first thing we're going to do is think back to Algebra 1. And when we were looking to factor in Algebra 1, our first step was to look for a GCF. So our GCF here is 4. I'm going to take out a 4, and I'm left with 8x cubed minus 8x squared plus x minus 1 and let that equal to 0. If I can put it in its factors, then I can determine the roots by setting each of our factors equal to 0. I'm going to divide by 4 to both sides. So 8x cubed minus 8x squared plus x minus 1 equals 0. Right now our polynomial equation has 4 terms. If it was 2 terms, I'd be looking for the difference of perfect squares. If it has 3 terms, I'd be looking to reverse FOIL. This has 4 terms, so I'm going to look to see if I can group. I'm looking for common factors in the first 2 and the second 2. Well, the first 2 have a common factor of 8x squared, and when I factor that out, I'm left with x minus 1, which is the third and the fourth term. So I'm going to factor out that x minus 1, and in the first part, I'm left with 8x squared and plus 1. Since we have 2 factors being multiplied that equal 0, either the first factor equals 0, or the second factor equals 0, or both factors equal 0. So when we're finding our roots for our polynomial expressions, or our polynomial equations, we're setting our factors equal to 0 and solving. So here, we're going to add 1 to both sides, so x equals 1. On our second one, we're going to subtract 1 from both sides, so 8x squared equals negative 1. Then I want to continue to get x squared by itself, so divide by 8. So x squared equals 1 over negative 1 over 8. And I need to take the square root. Well, when I take the square root of an answer, I get 2 options, the positive and the negative. I've got the square root of 1 over the square root of 8, because I can split up that square root fraction. I want to rationalize this, so I know the square root of 8 can be split up into the square root of 4 and the square root of 2, but I can't have a square root of 2 in my denominator. So I'm going to multiply the numerator also by the square root of 2. So I've got x equals positive and minus the square root of negative 1, that's I, times the square root of 2, over the square root of 4 was 2. We multiplied the denominator and the numerator by the square root of 2, so times 2, and our denominator is 4. So our roots, our solutions, is the real 1 and 2 complex positive and negative I times the square root of 2 over 4. And double checking our polynomial equation that we started with, it has a degree 3, and that's what we found, the 3 roots that are associated with that.